Kinetic energy is the energy an object has because of its motion. All moving objects have kinetic energy. Kinetic energy depends on two things: the mass of an object and the speed of an object. Mass is how much matter something has. Speed is how fast something moves. Which object does not have kinetic energy? A group of students want to do an experiment to investigate kinetic energy. They know that mass affects kinetic energy, but they do not know how. They do some tests to find the relationship between mass and kinetic energy. The students choose different balls that have different masses. The balls are made of different materials, but are the same size. Then they drop the balls from the same height. The balls fall on a large piece of clay. Each ball leaves a hole when it hits the clay. The students measure the diameter of the holes made by each ball. The students calculate the volume of the holes that the different balls make. They then graph the mass and average hole volume. Look at the graph in the picture. Volume and mass have a linear relationship. The greater the mass, the greater the volume of the hole. The different balls make holes with different volumes. This shows us that the balls have different amounts of kinetic energy. Because the balls are falling and are in motion, this energy is kinetic energy. More mass means a larger hole. At the same speed, more mass then means more kinetic energy. Which of the following graphs shows the correct relationship between mass and kinetic energy? Changing mass changes the kinetic energy by the same amount. This is a proportional linear relationship. Decide how the kinetic energy changes in each picture. In this lesson, you learned that mass and kinetic energy have a proportional linear relationship. The greater the mass of an object, the greater its kinetic energy. What about speed? In this activity, you will investigate the relationship between speed and kinetic energy. A group of students do an experiment to find how the speed of an object affects its kinetic energy. Using the same setup as in the previous activity, they drop a small stone of mass 26 grams into the clay. Each time they drop the stone at a different height, they calculate the volume of the circular hole formed in the clay. They then record their data in the table as shown. What do you notice happens to the volume of the hole as you drop the stone from greater heights? The students then graph the heights dropped and the volumes of the holes the stone makes on the clay. Look at the graph in the picture. The greater the height, the greater the volume of the hole. Volume and height have a square, nonlinear relationship. Which of the following graphs shows the correct relationship between speed and kinetic energy? How does changing the height from where the stone is dropped changes its motion? Changing the speed of an object by a factor changes its kinetic energy